So today we're going to go over a sample final exam from last semester. I have all the questions listed here on the PowerPoint. I'll solve each of them as we go. And if you have any questions, feel free to stop me and ask. All right. So the first one, suppose your neighbor is trying to sell his house. So your yard is a complete mess. It would cost you $1,500 to clean it up, and you don't care whether it's clean or not. If you do clean it up, though, that would increase your neighbor's property value by $2,800. If your town does not have any laws that require you to clean up, what does the cost theorem suggest will happen if there are no negotiating costs? All right, so we have two options. You either clean up your yard or you do not. What do you think is going to happen if you negotiate with your neighbor? Are you going to clean up or not? Yep? You're going to, right? That's what Coase's theorem tells us. That whenever there are no negotiation costs and the two parties are allowed to bargain with each other, the socially optimal outcome is going to be reached. And to think about it in those terms, let's figure out what society is going to get in the two cases. So on one hand, you have, first of all, you have the option to clean or not to clean. All right? What are the costs and what are the benefits in each case? And then what is the net for society? So first of all, if you do not clean, then the cost is zero, right? You don't pay anything, but nobody gets anything either, right? So there's zero benefit to your neighbor. If you do clean, the cost to you would be $1,500, right? So it will be negative $1,500. However, your neighbor is going to get a positive $2,800. So the net would be a positive $1,300. Whether the net, when you don't clean, is nothing. Right? So we know that if you do negotiate, you're going to reach the socially optimal outcome, which maximizes the social welfare. However, since your town does not have laws that require you to clean, what does need to happen for you to clean? Remember, it costs you $1,500, right? So what's going to incentivize you, and who's going to incentivize you to pay that $1,500? Your neighbor, right? So they need to pay you at least $1,500 in order for you to clean up. Would they be willing to do so? Yes, right? Because the benefit for them is higher. So they'll be willing to pay you up to $2,800 for you to clean. Right, so now let's look at the answers. You decide not to clean up your yard. Is that true? No. Your neighbor pays $1,200 to clean up your yard? No, right, because it's going to cost you $1,500. Why would you clean it up for $1,200? Your neighbor forces you to clean up your yard. They cannot do that because the town laws do not require you to do so, right? And finally, your neighbor pays you $2,000 for you to clean up. Now that makes sense. And they'll be willing to do so. Once you get the $2,000, you would also be willing to clean up. All right, does that make sense? All right, so the answer here is D. You have a question?
Yeah. Whenever we have Coase theorem, the answer is usually going to be in between both, right? So if like the $1,500 and $2,800, the answer is going to be in between.
All right, so the question was, whenever we have Coase's theorem at play, would the answer always be in between $1,500 and $2,800? Well, that's not necessarily true. What if it were the other way around, right? What if it cost you $2,800 to clean up, and your neighbor only benefit was $1,500? Then negotiating is not going to work, right? You're not going to clean up because it doesn't make sense for your neighbor to pay you that much, $2,800, for you to clean up. So the socially optimal outcome would be still don't clean up, right? So it's not necessarily always the case. Just in this case, that's what happened. Right? So the answer here is D. All right. All right, so the second question, we have a payoff matrix. We have two parties, firm 1 and firm 2. Each of them has three possible strategies. For firm 1, that's ABC, and for firm 2, that's XYZ. The question is, which one of the following is a Nash equilibrium of the game? So the way that I suggest you answer any question that has to do with game theory and payoff matrix is to put yourself in the shoes of each of the players separately, and then see what their optimal strategy would be given, right, the strategy of the other person. So for example, if I'm firm 1, right, I have choices A, B, and C. Now, given what firm 2 does, what is my optimal response? So consider the 3 possible actions of firm 2. First of all, firm 2 can go with X. Right? If they go with X, what is my best strategy? What should I do? Wait, so the first number here represents the payoff for firm 1, and the second number represents the payoff for firm 2. Right? So if I'm firm 1, given that firm 2 chooses X, what is the best possible scenario for me? What should I choose? B, right? Because in A I'll get 6, B will give me 7, and C will give me 5. So B is going to be my optimal response if they choose X. And okay, so another trick to do is just circle it. Circle the best the optimal choice for each player. Maybe use different colors or use circle and square. And then whenever there's an overlap between the strategies, that's going to be your Nash equilibrium. Right? So in this case, I'm going to use circles here. So that's my optimal strategy in the first case. Now I'll consider the second case. What if firm 2 chooses Y? All right, so I'm here now. If firm 2 chooses Y, what is firm 1's optimal response? C, right? Because it gives me 7 versus 2 versus 4. All right? And then the last one, if they choose Z, what is my optimal response? A. Right. So looking at those results only, does firm 1 have a dominating strategy? A dominating strategy? Just looking at this. Yes or no? No. And a dominating strategy would be basically if you had only C's, right? Or only B's or only A's. It means that no matter what the other person does, I'm always going to choose that option. But we see that that's not the case for firm 1. OK, now we're going to repeat the exercise, but looking from the other firm's perspective, from firm 2's perspective. And again, we're going to ask ourselves, and let me use another color for them. We're going to ask ourselves, what is the optimal response for firm 2 if firm 1 chooses A? All right, so now we're looking at these options. And remember, it's the second number that is the payoff for firm 2. So if firm 1 chooses A, what is firm 2 optimal response? Y, right? Because it gives it 8 versus 7 versus 4. So that's one of the options. Then again, if firm 1 chooses B, what should firm 2 choose? Y again. All right? So, and then if they choose C, what is the optimal response of firm 2? Y. All right, so now does firm 2 have a dominating strategy? Yes, and that's Y. Right, so whatever firm 1 does, I don't care. I'm always going to choose Y. All right, so that's not the question, though. The question is, which of the following is a Nash equilibrium of the game? So now we look at the overlap. If there's an overlap, that's a Nash equilibrium. Is there an overlap? Yes. And the strategies that give you the overlap are C and Y. And there's only one Nash equilibrium in this particular game. Right? There might be more, there might be none. All right, so this one is, what is it? CY, and that's B. Question?
Wouldn't it also be, like, since we only found, like, 3 options were BX, CY, and jump.
Sorry.
C, don't you just, like, add those 2 numbers together to see which one's the highest?
Can you repeat that? Sorry.
Like, from X, you got 7, 6. Add those together, that would be 13. And Y, the highest is 7, 10. Add those together, that would be 17.
All right, so the question is, shouldn't we add the 2 payoffs together to arrive at the best possible outcome? And the answer is no, because each firm is maximizing its own payoff. They don't care what the other firm gets, right? They're 2 different players, and they make the decision based on what is best for them. Okay, and so in no case would it doesn't make sense for firm 2 to go with X, right? Because even though the payoff here is higher for both of them, it is not the highest it can be for firm 2 itself. Right? So they would look at it from their own perspective. They're not optimizing the social value, just their personal payoff. Right? So answer B in this case. Now the same matrix. How many Nash equilibrium exist in this game? One, right? In this case, it's only one, and we figured that out. So that would be A. There. Okay. All right, so the following is an export from a recent Business Week article. The Prime Minister needs to speed up structural reforms, say the IMF and the US-Japan Business Council. One aspect of those reforms is guiding the Trans-Pacific Partnership Trade Pact through the diet. And yeah. So the argument is that the trade deal would generate jobs, boost growth, and assure a new era in our agricultural policy. But Japan's largest farm lobby is demanding that the government compensate producers hurt by the deal, and warned in October that there are growing voices of unease and anger in farming regions. All right, so interpretation. There's going to be a deal between the US and Japan, and the farmers in Japan are going to be hurt by it. All right, that's the gist of it. That's basically what it's saying. If that's the case, what is most likely true regarding Japan and the global agriculture market? All right, so in what sense would open trade, world trade, is going to hurt producers in one country? If those producers, well, let's think of it this way. So first of all, let's look at the options. Japan is able to produce food at lower cost than the rest of the world, causing them to import much food. First of all, if they're producing at a lower cost, are they going to import? No, so that's not going to be true in any case. Japan is able to produce at lower costs, causing them to export. That's possible, right? If they're producing at a lower cost, then they're exporting the good. It produces at higher costs, causing them to import. That also could be true, right? When you produce it, when domestic production is expensive, then you need to import. They produce at higher cost, causing them to export. If they produce at higher cost, there's no way for them to export. All right? So it's those two options that we need to consider. And in only one of those two are Japan farmers going to be hurt. When you have open trade, so if you start with domestic market, supply, demand, this is the domestic equilibrium, right? This is price quantity, supply, demand, right? This is the domestic equilibrium in terms of price and quantity. So this is producer surplus here. Let me use another color. And this is consumer surplus. If the world price, right, if we open trade and the world price is higher than the domestic price, right, if it's here, what happens then? We're going to have more supply than demand. So we're going to export. And then the consumer surplus is going to decrease for domestic users, but the producer surplus is going to increase. Right? Then producer surplus will become this whole thing. On the other hand, if the world price is lower, if it's somewhere here, then what happens? We have more demand than supply, so we're going to import the good, correct? And when we import the good, the producer surplus is decreasing from this whole thing to only that part here. So producers are hurt when the world price is lower. Right? Does that make sense? So what happened here is that Japan is able to produce at higher costs, therefore importing the food. And if that's allowed, the producer is going to be hurt, and that's why the farmers are complaining. Right? So it's, what is it, C in this case. Question?
So if they benefit from this new deal, then they would produce it at a lower cost and export?
If they were able, yeah, if they were producing at a lower cost, then the trade agreement, opening world trade, is going to benefit producers. But the consumers are going to be hurt. All right. So answer C here. All right. So let me read this out to you. So we have the following scenario. The demand for butterbeer can be represented with this demand curve, and the supply with the supply curve that we see, where the quantity is in thousands and the price is in dollars. The question is, what is consumer surplus in this market? Right. So in any market, if you look at the graph, okay, so we have price, we have quantity, we have a supply curve and a demand curve. They reach a certain equilibrium quantity and equilibrium price. Right? And then the question is, what is consumer surplus? So consumer surplus, by definition, is the area below the demand curve above the price. Right? So this area here is our consumer surplus, and that area is producer surplus. Correct? The sum of the two makes up the total surplus. Right? Now our question is, what is consumer surplus? We have the exact numbers, right? We have the demand and the supply curve. However, even if we don't, we can figure it out in terms of variables. So consumer surplus would be the area of this triangle here. This triangle here is a right triangle. So it's one side times the other side divided by 2. What is the magnitude of this side? Well, it's the difference between the demand curve intercept, right? So this is the intercept of the demand curve minus the price in equilibrium. Right? That will give me this side. And the other side is just the quantity in equilibrium. So if you want to express it as a formula, this is what consumer surplus is going to be like, and then divide by 2. Now I just need to plug it in, the information. So I know what is the intercept of the demand curve in our case. 20, right? We have the demand curve expressed in terms of the quantity. The intercept is 20, so I know this point is 20. And what's the intercept of the supply curve? 2, so I know that point is 2. I do not know at this stage the optimal price and optimal quantity. How can I find those out? Yes?
Make the two equations equal.
Exactly. I know that in equilibrium, both the price and the quantity are going to be the same, right? Because that's when the two curves intersect. So the price of the supply curve and the price of the demand curve is going to be the same. So I can set the two equations equal to each other and then solve for the quantity, because quantity is going to be the same as well. So I'm going to set in equilibrium the supply curve and the demand curve give you the same price because they intersect. Therefore, what do I have? So 20 minus Q, and I can call this Q star, right? Because that's going to be the quantity in equilibrium. So 20 minus Q star divided by 2 is going to be equal to 2 plus, again, Q star divided by 3. Now I have one equation, one unknown. I can solve for the optimal quantity. Once I have that, I can just plug it in either of those equations to find the optimal price. Correct? Right, so let's see what we have. We have, what is this, 18 equals Q star over 2 plus Q star over 3. The common denominator is 6. What is this, 108 equals 5 Q star. And Q star equals, what is it, 21 something, I believe. 21.6. All right, so I know this point is 21.6. Now I need to find the optimal price too, so I'm just gonna plug it in somewhere. Doesn't matter which equation you choose. So I'll do the demand equation. So the optimal price then is going to be equal to 20 minus 21.6 divided by 2. And that's 9.2. Right. So now I have all the information that I need in order to solve for consumer surplus. Right? I'm just going to plug it in, and I get, so the intercept is 20 minus the price in equilibrium is 9.2 times the quantity, which is 21.6, the whole thing divided by 2. And all right, so that I think the answer is 116, pretty sure. Yeah. So this is 116.64. However, quantity is in thousands, right? So I need to multiply by 1,000 to get it in dollars, and that would give me a consumer surplus of 116,640. Right? Any questions? So the area below the demand but above the price is 116.64. The answer is D. All right. So the same scenario. Again, price and quantity. The question now is, what would be the deadweight loss from sales tax? Wait. You can see there. I'll read it out for you. So what would be the deadweight loss from a $1 tax on producers? So this says $1 tax on producers. All right. So we have the same scenario. We found out what the optimal price and the optimal quantity is. Now we're going to impose a tax on sellers. A tax of $1 means that we're going to be shifting the supply curve 1 unit to the left, right? So we're going to impose the tax that shifts the supply curve because it's on producers. That's the new supply curve now, and that's the new equilibrium. And I know the vertical difference between the two curves is going to be 1, right? So this distance here is going to be the amount of tax, which in this case is $1. And what happens when you impose a tax? The new quantity in equilibrium, the after-tax quantity, is lower. And that's the consequence of a tax, because the market just shrinks. Right? The quantity produced and bought is now lower. What is the deadweight loss? The deadweight loss is the decrease in total surplus due to the tax. And total surplus used to be the area of that triangle. That's the optimal one when there's no tax. But now the market is smaller. Now the optimal quantity is decreased. So total surplus is decreased to this trapezoid here. And the deadweight loss is the decrease in total surplus. So the deadweight loss would be the area of that little triangle. Agreed? Again, if you want to express it in terms of the variables, not necessarily the numbers, what would it be? Well, it's a triangle. So the area of triangle would be the base times the height divided by 2. We know the base is going to be the amount of the tax, for sure. Whatever the tax is, the base of that triangle, the difference between the two curves is always going to be equal to the amount of tax. So the deadweight loss could be expressed as whatever the tax is times, now what is the height of this triangle? How can you express that? Yes? It's the change in quantity. It's the loss in quantity due to the tax. The reduction in quantity due to the tax. So it's the optimal quantity minus the after-tax quantity. That's going to be the size of this side here, and then the whole thing divided by 2. Okay, so we know the tax is $1. Right? We can just plug that in. We know the optimal quantity from before. That was 21.6. What we do not know is the quantity after tax. So we need to calculate that first, then plug it into the formula to find the deadweight loss. The after-tax quantity, well, there's just, again, we need to set up the two curves equal to each other. However, now the new supply curve is, as I said, shifted with the amount of the tax. That's one way to do it, which would basically increase the intercept from 2 to 3. Alternatively, you can just notice that the difference between the two curves is now the amount of the tax. So you can set the difference between the two equal to 1. Both of those will give you the same result. Doesn't matter which way we go. So the demand curve now is going to be equal to the supply curve plus the amount of the tax. Okay? And I can set that up. 20 minus, now this would be the, because in that case, the quantity is the same, so I can just call this the after-tax quantity. What is that, divided by 2? It's going to be equal to the supply curve, which is 2 plus, again, the after-tax quantity divided by 3, plus the amount of tax, which is 1. Okay, so now I'm solving for that. What do I get? 10, that's 17, equals the after-tax amount over 2, plus the after-tax quantity over 3. Again, multiply by 6 both sides. After-tax quantity is 20.4. Right? So now this is going to be 20.4. Now I'm all set. I just need to plug it in back into the formula. All right, so the tax is 1, and this was 21.6 minus 20.4. The whole thing divided by 2. So what is that? 1.2 divided by 2? 600. All right, so this will be 0.6. Deadweight loss is 0.6, however, quantity is in thousands again, so we multiply by 1,000. Then it becomes $600, which is answer C over there. All right. Any questions? All right. Okay, we're done with that scenario. So it really helps to have the graph. Whenever you have a problem with the demand and supply curve given as an equation, it really helps to draw the graph and to mark everything as you find it.
How would it have been different if there was X on the consumers?
Well, then the demand curve would have been shifted. However, the difference between them would still have been 1.
Okay.
Right?
Because it's just the size of the tax.
Right. It doesn't matter who pays the tax. Right? They're always going to share the tax based on the elasticity of demand and supply. However, what you're after here is the quantity after tax. Right?
Would we have added the 1 on the left side of the equation?
No, it would still be exactly the same result.
Okay.
Right? It's just the demand curve would have been shifted down.
Okay.
So this would be the demand curve minus 1
Okay.
equals supply, right? And then it's exactly the same thing. It doesn't matter. The difference is always going to be the amount of the tax. So the demand minus the supply is always going to be equal to the amount of the tax. Okay? All right. All right, now we have cost curves, right? This is the general picture that you've seen many times before, the average total, average variable, and the marginal cost curve for a firm. And we're going to be answering questions about that picture. So the first question is, what is the firm's shutdown price? So a couple of things to note. When you have average variable, average total cost, the marginal cost curve is always going to intersect those curves only once, and that's at the minimum of both of them. Right? So the marginal cost curve intersects the average variable once at its minimum, and it intersects the average total at its minimum. That's always going to be the case. Okay? What is going to be the shutdown price? Right. So the shutdown price, the idea is that it's a short-term phenomenon. So the idea is it worth it for the firm to operate in the short term or not? We know in the short term, you're not so flexible. So even if you don't produce any units, you're still going to pay the fixed cost, right? So in the short term, the fixed cost is always going to be there for you. The question is, what price is going to make me indifferent between operating and paying both fixed and variable, or not operating and paying just fixed, right? The answer to that question is the price that compensates me exactly for the variable cost, right? if the price is high enough so that it pays for the variable cost of the units that I produced, whether I produce them or don't, I'm still going to pay the fixed cost and get nothing more out of it. Okay? And we know that they always operate, so marginal revenue equals marginal cost. That is the optimizing decision. And they're going to get the prices given, so that's always going to be equal to the price. So what price that is equal to marginal cost is also equal to average variable cost? That's the question. The shutdown price would be where, basically where marginal cost intersects average variable cost. And that's at this point here. And looking at it, it's 4.25, right? It's a bit above 4, and the closest answer is B. So that would be 4.25. At that price, would the firm operate at a profit or at a loss in the short term? It would operate at a loss, and that loss is going to be equal to exactly its fixed cost. Right? Does that make sense? All right. Okay, next question, same picture. What are this firm's approximate fixed costs? So now we need to find what the fixed costs are. We don't have the average fixed cost curve here, right? But we do have the average total and average variable. We know that the total cost is the sum of the fixed and the variable, right? The total is the sum of the total fixed and total variable at any quantity, right? So that's the fixed cost plus the variable cost. We have everything in terms of averages, right? So to get this formula in terms of averages, I can just divide both sides by Q, right? So if I divide by Q, everything, then I would have the total cost divided by Q is what? Average total, right? So now I have the following formula. Average total cost equals average fixed cost plus average variable cost. All right? This is going to be true at any quantity. So at this point, what I need to do is just pick one quantity, doesn't matter where. And looking at the graph, I can figure out what the average total is and the average variable is. Given those two, I can find the average fixed at that quantity, correct? And I would suggest just picking one that, you can easily see what the two costs are. I think I chose 11 here, right? So at 11, at the quantity of 11, my average variable cost is around 5, right? And at quantity of 11, my average total cost is about 10. Okay, so at Q equals 11, so average total is 10, average variable is 5. So what is average fixed at that quantity? 5. Well, if average fixed cost is 5 and quantity is 11, that would allow me to find the total fixed cost, right? I know fixed cost is, I know average fixed cost is fixed cost divided by Q. So fixed cost then, which is what I'm after, is going to be average fixed times Q. Okay? And I have both of them. Average fixed is 5, Q is 11, so it's approximately 55. All right? What is it? 5 times 11. It's 55. The closest answer is 56, because we rounded up here a little bit. Okay? And that's my fixed cost for the firm. It's $56, which is answer C. Questions? All right. So again, the same picture. Assuming the firm was already in the market, what would be its profit if the market price were $5? Okay. So the market price is $5, just here. I'll clean this up. Again, the optimizing rule is they're going to produce where price equals marginal cost, or marginal revenue equals marginal cost. So if the price is $5, they're going to be producing here, right, where it equals marginal cost. And this is at approximately a quantity of 8, let's say, right? So the price is 5, the quantity produced would be 8. Question is, what is going to be the firm's profit? Right? So profit is always going to be equal to total revenue minus total cost. Right? That's always going to be the case. We can also express this total revenue, that's the money you receive when you sell products, right? And total revenue is always going to be the price that you sold it at times the quantity that you sold. Okay? Total revenue is also price times quantity. Total cost is could be expressed as the average total cost times the quantity, right? Minus average total cost times quantity. So I can express the profit equation as the difference between the price that you sell at, the average total cost for the good, times the quantity that you're going to sell. So looking at this equation, we can see that whenever the price is lower than the average total cost, we're going to have what? If the price is lower, right, this becomes negative, so we have a loss. If the price is higher, then we're going to have a profit. At the quantity of 8, just here, what is average total cost? Well, it's about 11, right? So are we going to operate at a profit or at a loss? Loss. Okay, so A automatically out, because it says a profit, as well as B. Okay? The only options are C or D. Now what's left is to find out exactly what the loss is. This is just plugging it in. All right, at the price of 5, average total cost is 11, and quantity is 8. Well, 6 times 8, 48. Negative. All right, so the company is going to operate at a loss of $48 roughly. Okay? What is going to happen in the long run in this case? This is short term, right? Short term, they're not flexible enough to, right? So question?
No, profit equals 0?
Right, in the long run, profits are going to be equal to 0, but how do you achieve that outcome? Well, this firm is operating at a loss. It's not going to be operating at a loss forever. Some of the firms in this market are going to choose to exit, right? As firms exit, we're going to be moving, the price is going to go up, right? Supply is lower. When supply is lower, the price goes up. As more and more firms exit, the price is going to be going higher and higher until it reaches the point where profits are exactly 0. At that point, nobody has any incentive to either enter or exit. And that's going to be perfect competition, optimal outcome in the long run. Okay? All right. The next one deals with this a little bit. So if all firms in the market have identical cost curves, and if the market price were currently $12, then what would happen in the long run? All right. So now the market price is 12. Market price 12 means that you're going to, again, marginal revenue must be equal to marginal cost. So the price must be equal to the marginal cost. So you're going to be producing at this point here, which is about 12 units. At that point, are you going to be making a profit or a loss? A profit, right? Because at 12, the average total cost is lower than the price. Okay? So the price of 12 is higher than the average total cost, which is about 10 in that case. So you're going to be operating at a profit. What happens in the long run then? Firms will enter, right? So other firms are going to see this industry is profitable, so they're going to want to join, and this is going to be perfect competition, so they'll be allowed. There are going to be no barriers to entry. They're going to enter the market. As more and more firms enter the market, supply increases. When supply increases, the price goes down, right? So firms are going to start entering, and they're going to drive the price down up until it reaches 10, which is where profits are 0. then again, nobody has an incentive to either enter or exit. Okay. And that will be answer. Firms would enter, and the price will fall. So let's see. Okay. Questions? All right. Okay, we're done with that scenario. All right, which firm has a dominant strategy? Okay, so that's a payoff matrix, game theory. And as before, I suggest just, again, looking at it from one firm's perspective, given that the other firm chooses option 1 or option 2. And then we're going to see what's going to happen in this case. So I'm firm A, right? I'm first going to ask the question, should I go with low output or high output, given that firm B goes with low? Right? So if firm B chooses low, what is my optimal response? High, because that gives me 125. All right? So that's the one. And again, if firm B chooses high, what should I do? High too. So does firm A have a dominant strategy? It does. It should go with high no matter what firm B does. Okay? Then repeat the exercise from firm B's perspective. Now on firm B, what's my optimal response if firm A chooses low? Which one? High, right? Because it gives me 135 versus 120. And again, if firm A is to choose high, what should I do? High. All right. There's the overlap here. And does firm B have a dominant strategy? Yes. In either case, they're going to choose high output. All right? So the question is, which firm has a dominant strategy? Both. Right? Both of them have a dominant strategy, which is always high output. So that's answer C. Where did I leave? Which combination of strategies is the Nash equilibrium? Again, we only have one Nash equilibrium in this case, and that's high-high. Right? The Nash equilibrium is when there's an overlap. And that's both firms produce high output. That's answer B. Agreed? Now, if you look at it, is that the best option for both of them? And is that the socially optimal option in general? No, right? Because if you compare, let's say, low-low to high-high, both of them are better off, individually and collectively, right? If they go with low-low. And what is that type of game called? Prisoner's dilemma. Right? This is where if they're allowed to collude, right? If they're allowed to collaborate and agree on the strategy, both of them would choose low output because that maximizes their individual return or payoff. However, the problem with that outcome is that each of them has an incentive to lie. Right? Each of them has an incentive to deviate. For example, if they agreed on low output, and I'm firm A, right? I agree on low. However, if I cheat, I'll get 125 instead of 100. Right? So I'm again maximizing my own utility. So even though I agreed, I have an incentive to cheat. And the same is true for firm B. Right? Even though we agreed on 120, if they cheat, they get 135. So they're better off. And that's why the prisoner's dilemma gives you the suboptimal outcome. Right? Because they cannot commit to the best for both of them. So they're going to be both of them are going to end up cheating. And when they both cheat, both end up with the lower payoffs. Right? That's why it's Nash equilibrium. All right.
So you said there's a socially optimal outcome as well?
Yes. The socially optimal, well, from a social planner's perspective, the idea is that you want to be maximizing total output or total payoff for everybody, right?
Socially would also be for the firm.
Yeah. Socially would be basically adding the numbers together and see where is higher. If you can force the players to behave in the socially optimal way, then that will be the best outcome for society. Right? But this is assuming that only those two firms exist in society, right? And that's not necessarily going to be the case, because here we basically talk about those are just producers, and when they collude, right, there's consequences for the demand side, right, for consumers. Right? But in general, what maximizes the total? This is 160, this is 185, this is what, 210, and this is 220. All right, so this will be the highest one, yeah. There was a question over there?
Yeah, I was going to ask for Nash, is it always when they're equal?
Sorry?
For Nash, is it always when they equal each other?
The question is, for Nash, is it always when they're equal to each other? No, that could have been 70. That could have been 60, doesn't matter. They would, yeah, they overlap. It's always when they overlap. The numbers, I mean, they don't necessarily have to be equal. They don't have to share the same payoff. This just happened to be that case. Question?
In general, are Nash equilibriums never the socially optimum?
In general, are Nash equilibriums never the socially optimum? In Prisoner's Dilemma, yes. Not necessarily in other games. And again, we don't know. This is not. I mean, we're not really sure what's the socially optimal in this case, because we only have 2 players. If there are other players in the market, then we need to consider. This could end up being the socially optimum because consumers are going to get a lower price, right? And that could, in general, increase the total surplus. Okay? It is hurting producer surplus, but the benefit in terms of consumer surplus might be high enough to compensate for that. Okay? All right. Which of the following is true for a 2-person game which has a Nash equilibrium? Only one of the 2 players will have a dominant strategy. Is that necessarily true? No, we just saw that both of them had a dominant strategy. We still had a Nash equilibrium. The game must have a dominant strategy equilibrium. Not necessarily. It might not have dominant strategy and still end up with a Nash equilibrium. Right? The dominant strategy of the players must be different. They don't have to be, right? And the game may or may not have a dominant strategy equilibrium. That's the one, right? So it's D. Okay. In country Marlboro, cigarettes are forbidden. So people trade them in a black market. We have the demands for cigarettes and the supply for cigarettes in that black market. The question is, what is the equilibrium price and quantity? All right, so the same idea. We have 2 curves. We have 2 equations that, in this case, they're written in terms of the quantity expressed as a function of price. Right, so be careful. In that case, the intercept, well, the intercept is the same, but generally the demand curve is price expressed as a function of quantity, right? Because this is price, this is quantity. So in any equation, this is y, this is x, and usually express y in terms of x, right? Y equals intercept plus slope times x. In this case, it's the other way around, so just be careful about that. For our purposes, it wouldn't matter for this question, because we just need to find the equilibrium quantity and price, and they're both the same when the curves intersect. All right, so I'm going to, again, quantity price at equilibrium is what I'm after. Supply demand. Okay, I can set them equal to each other. I know the quantity is going to be the same, so I can say that 12 minus the price in equilibrium equals 2 times the price in equilibrium. Then solve for the price. Once I have the price, then plug in any of those 2 to get the quantity. Okay. So what is it? 12 equals 3 times the price in equilibrium. So the price in equilibrium equals $4. Right, so that's 4. and quantity would be 8. Right? I can just plug it in either of those two. So 2 times 4 is 8. Quantity is 8. All right, so which answer is that? C, right? Price 4, quantity 8. That's straightforward. All right. Again, the same scenario. The question is, the price elasticity of demand is equal to what? And this means that the demand for cigarettes in equilibrium is elastic or inelastic. Right, so we need to calculate the elasticity of demand. So be careful. The elasticity of demand and supply in most cases are different at equilibrium. So in this case, we're asked about the demand curve. And just looking at the answers, can we eliminate some of them? Right. For example, if it's 1/2, if it turns out that the price elasticity of demand is 1/2, would that mean an elastic curve? No. All right. So that's definitely not the case. If it's 1/2, it would mean inelastic. So that's possible. If it's 2, what would it mean? Elastic or inelastic? Elastic. So A we can also eliminate. That's never going to be the case. All right. And now you have 50% chance of answering that question correctly, even if you don't know how to calculate it. But we do know, right? So the price elasticity of demand at equilibrium, so at the equilibrium point, we know the formula is 1 over the absolute value of the slope, and that will be the slope of the demand curve, not the slope of the supply curve, right? Times, what is it, price over quantity. The equilibrium price divided by the equilibrium quantity. That is the point elasticity formula. So we know the price and quantity in equilibrium, right? It's 4 and this is 8. And what is the slope of the demand curve? So the slope of the demand curve, now in this case it's okay because it's -1, but if it were that, what would be the slope of the demand curve? Sorry?
-2.
Do we agree? Would it be -2 or -1/2? It would be -2, right? To find the slope, we need to express this equation in terms of price equals something something quantity, right? So I would need to solve for the price basically. In the original equation, the price would be equal to 12 minus the quantity, right? So the slope is -1. Therefore, the elasticity becomes 1 over 1 times 4 over 8, or 1/2. However, if it were the other way around, if it were quantity equals 12 minus price over 2, right? Then I would have price over 2 equals 12 minus quantity, right? And then, but I still don't know what the slope is. I need to express it in terms of price by itself. So that would be 24 minus 2 times quantity. And now the slope is -2, right? So be careful about that. Right. In this case, that didn't have, well, basically it's the reciprocal. Whatever the slope of the slope here is in this equation that is expressed in terms of Q, the slope of the demand curve or supply curve would be the reciprocal of that. The reciprocal of 1 is 1, so we didn't have that problem in this case. All right, so 1/2 is the slope of the demand curve, therefore inelastic. And B. All right? Same case. Marlboro legalizes cigarette and opens to the international market, where the world price is 10. Then would they export, import, and how much? And how large would producer surplus be? All right. So what we found here, this is the domestic market, right? Domestic price is 4, domestic quantity is 8. Now when we open the world trade, we open this market for international trade, and we have the world price being 10. So the world price is actually higher than the one we have here. Let's put it there. So the world price is 10, then what happens? Well, at the world price, the producers at Marlboro will want to produce a lot. But the demand, the domestic demand, is going to be lower. So what do they end up doing? Exporting. And they're exporting this quantity, which is the difference between the supply and the demand at the world price. So here we're going to have quantity supplied at the world price, and here we're going to have quantity demanded at the world price. The difference is in terms of exports. Right, so we can eliminate A and C, right? Because they're telling us we're going to be importing. That's not the case. And we know that exports must be 18, because that's all we have given, right? So this must be 18. But we can calculate it nonetheless. But we have it there. There's no other option. So they're going to export 18. However, the other question is, what is producer surplus? OK, so producer surplus is the area above the supply curve, but below the price, by definition. All right? When you have international trade, then the producer surplus, and they're exporting, the producer surplus is going to be this whole area. So it is increasing compared to only the domestic market. In the domestic market, the producer surplus was just this triangle here. Now it's higher. And what it is? Well, to express it in terms of a formula, again, this is a right triangle. So this side is the quantity supplied at the world price. Okay? And the other side is the difference between the world price and the intercept of the supply curve. Right? Do we see that? The quantity supplied at the price, at the world price, times the difference between the world price and the intercept of the supply curve. The whole thing divided by 2. All right, what is the intercept of the supply curve? If you express this in terms of price, then we have price, guys, please. We have price equals quantity divided by 2, right? So the intercept is? The intercept is y equals b plus mx, right? Price equals, q divided by 2. And what is b? In our case, 0, right? So the intercept, the supply curve is actually going through the 0, 0 point. All right, so I know this is 0. I know the price, the world price is 10. I don't know what the quantity supplied at the world price is. That's what I need to figure out. I know it's something more than 8. Well, the quantity supplied is 2 times P. And at the world price, that would be what? The world price is 10. So that will be 2 times 10 or 20. So now this is 20. Correct? So what is this then? The quantity demanded at the world price. What is the quantity demanded at the world price? 2. Right? Because it's 12 minus 10. So it's 2. Then the producer surplus would be the quantity supplied, which is 20. Right? This is this side of the triangle, times the, well, in this case, just the world price, which is 10. The whole thing divided by 2, 100. Okay? So if they open the international market, they would export 18 units, and producer surplus would be 100. So that's answer B. Okay? All right. Okay, so now we have another scenario. Susan is opening a bar and she hired 2 guys. She needs our help to decide what is the most efficient way to allocate the hours of work between the two people that she hired, which are Pedro and Kunal. So they're going to work from 6 p.m. to 2 a.m. That's an 8-hour period of time. One guy can produce 12 food platters or 10 drinks per hour, and the other guy can produce 30 drinks or 3 food plates per hour. Now we need to decide who's going to do what, right? And then allocate all their time to that particular activity, which is either food or drinks. How are we going to decide that? Well, we need to first figure out what is the opportunity cost for each person of producing, let's say, drinks, right? Opportunity cost is in terms of the other activity that they could be doing. So it helps to set up a table. So I have the K person and the P person, and they can either produce food or they can produce drinks. Kunal can produce 12 food plates or 10 drinks per hour. And Pedro can produce 30 drinks or 3 food plates. So to do this, the easiest way to do this is to analyze, right? So to analyze it for each person separately. And we've seen that a lot when we have countries, right? And we need to decide which country should specialize in what kind of activity or production. This is exactly the same idea. So for Kunal, what they can do is they either produce 12 food plates or 10 drinks. This is the equivalence sign. In 1 hour, they can do one of the two. Now, we're going to express the opportunity cost of one in terms of the other. So let's say we want to see how many food plates do they have to give up in order to produce one drink. Okay? To get that, I need to divide both sides by 10, so I can get just one drink here. Okay? And I get that one drink for Kunal equals 1.2 food plates. All right? Then do exactly the same for Pedro. For them, the trade-off is 3 food plates or 30 drinks. Sorry. Then express, again, the price of drinks in terms of food plates. Make sure it's exactly the same thing that you calculated there. So to produce one drink, Pedro needs to give up the production of, 0.1 food plates. Right? So this is now the opportunity cost of drinks for both of them. Who has a lower opportunity cost? Pedro. So the person with the lower opportunity cost, this is a cost, right? We call it opportunity cost, but it's still a cost. For whoever it's cheaper to do so, should be doing only that. So in this case, Pedro should produce the drinks, because for him it's cheaper to do so. And that is interpreted that when we have that case, we say that Pedro has a competitive advantage in the production of drinks. Right? So if one person has a competitive advantage in drinks, then it's automatically true that the other person has a competitive advantage in the other good. Right? So Pedro has competitive advantage in drinks, and Kunal has a competitive advantage in the production of food. So what we're going to do is have Pedro do all the drinks, and Kunal do all the food. Question? No?
So it's going to be true that the other person is going to have an opportunity advantage?
The question is it always going to be the case that when one person has a competitive advantage in one good, the other person is going to have the competitive advantage in the other good? The answer is yes, because the opportunity cost of drinks we express the opportunity cost of drinks here. If we want to express the opportunity cost of food, that will be the reciprocal of this number, all right? So one food plate is going to be equal to 1 over 1.2. And for this guy, one food plate is going to be equal to 1 over 0.1, right? So the opportunity cost of food is going to be, when it's reciprocal and when it's smaller, then the reciprocal is always going to be larger. Right? So it's always going to be the case. Once you find whoever should be doing one of the goods, then the other good, the other guy should be doing for sure. All right, so let's look at the question. Susan wants to produce 250 drinks per night. If they work together efficiently, how many drinks would Kunal produce? What do you think?
It is from 6 to 2.
Right, so it's from 6 to 2. Well, we are going to make Pedro produce only drinks, all right? But there's only so many that he can produce in an 8-hour period, correct? And how many is that? Well, he produces 30 drinks per hour. That's Pedro. So if he works 8 hours on only drinks, he's going to produce how many drinks? 240. So the question is, how many would Kunal produce? 10, the rest of it, because she wants 250, right? Susan wants 250, therefore Pedro is going to do 30 drinks times 8 hours, or 240, and Kunal will do 250 minus 240, or 10 drinks. And then with 10 drinks, he's going to produce them in an hour, because that's how long it takes him. And for the rest of the time, for the rest of his shift, he's going to be producing the food plates. All right, does that make sense? So the answer is B. Same scenario. Suppose the only economic activity that Kunal and Pedro are good at doing is making food plates and drinks. What is Pedro's opportunity cost of making 60 drinks? Now, since we already created the table and found the opportunity cost, it's actually pretty easy to answer that question. So for Pedro, we know that one drink, right, costs him 0.1 food plates. So how many food plates would 60 drinks cost him? 6, right? Just multiply both sides by 60, and B. All right. Okay, we have another scenario here. We have a small town. Only 2 residents, Kevin and Russell, own wells that produce safe drinking water. Each week, they work together to decide how many gallons of water to pump. They bring it to town and sell it at whatever price the market will bear. Suppose they can pump as much water as they want and it costs them nothing. Right? So marginal, total, fixed, all costs are 0. There's no cost for them to pump water and sell it. Right? So what that means is whatever revenue they get, that's going to be their profit as well. Right? Because profit is total revenue minus total cost. If there's no cost, then total revenue is profit. Now in this table, we're given the demand, so the quantity, basically the demand curve for water. We have the quantity and the price. So at which price, what quantity does the market demand? We're also given the total profit, or the total revenue, which in this case is also the total profit, at which price and at each price and quantity. All right, so the question is, if Kevin and Russell operate as a profit maximizing monopoly, how much profit will each of them earn? All right, so imagine that they're just one person now, right? That's what monopoly is. They're one firm. They're partners in a firm. Okay, so if they operate in this way, what would their goal be? And remember, they're the only 2 people that have access to that well. So there's pretty much no competition, and they're not competing with each other, they're colluding, right? So what would they want to do? maximize profits. And we know that that's what the monopolist does. In this case, what is the maximum profit that they can achieve? 90,000, right? So what they're going to do is they're only going to pump 300 units, okay? The market price will be 300, and they'll get $90,000 together, okay? But the question is, how much profit will each of them make? 45, right? Because they're going to split it into. Question?
This was an issue I had with the midterm, is that they didn't say that you can assume that they spread the money evenly. They didn't give that assumption clearly, and a lot of the questions I noticed don't label assumptions that could be considered obvious based on the question, you know what I'm saying? But
All right.
I feel like they
So
should
the question is that it's not indicated here that they're going to be splitting the profits equally. Logically, if that's not said, right, that's not indicated here. Look at the answers. The question is how much profit will each of them do, or each of them get. So if each of them gets 9, that does not equal 90.
But this,
For this is pretty obvious, yeah. But
for other problems, though, I noticed that there's a lot of assumptions, because it's a class based around assumptions, and sometimes they don't include some of them. So I think they should be more direct with the assumptions.
all right, so the suggestion is that, well, makes sense, right? So the question should be structured in a way that doesn't necessarily, that makes the assumptions clear, which is a note to your professors.
Yes.
All right. Okay, so this case was 45, answer C. Again, same scenario. What is the socially efficient quantity of water? Yeah? 600. What is socially efficient? Well, in terms of economics, when we say socially optimal, what we mean is the perfectly competitive outcome, right? We know that in perfect competition, the outcome that is reached is socially optimal. Now, what was one of the implications of the perfect competition? We are always at marginal revenue equals marginal cost, right? That's optimizing for any type of market, monopoly, monopolistic competition, perfect competition. That's always the case. However, only with perfect competition, marginal revenue is also equal to price. And that is because every firm individually in a perfectly competitive market is taking the price as given. They have zero control over the price. Okay? So in perfect competition, and the socially optimal outcome would be where the price equals marginal cost. What is marginal cost in this market? Zero, right? We're told that they don't pay anything to get the water. So marginal cost is 0, price is 0 here at a quantity of 600. So the socially optimal, in other words, the perfectly competitive outcome is going to be at a quantity of 600, where those guys pretty much, just transfer the water from the wells to the town and give it away. And that is because they have no cost. If there's some cost, right? If this was 1, or no, if this was 50, then the socially optimal would be 550, and so on and so forth. Right? So the answer in this case is D. All right, same scenario. This is a bit more. All right. Suppose antitrust laws are enacted to prevent Kevin and Russell from operating as a monopoly. All right, so they can no longer agree with each other on what to do. What is the price after they reach a Nash equilibrium where they can only increase or decrease production by 50 gallons? So each of them has the option to increase or decrease production by 50 gallons or stay where they are. So if we start with the monopolistic outcome, generally we know that what's going to happen with, this is called oligopoly, right? So when there's 2 of them, we're going to be moving in the direction towards the more socially optimal outcome. So we will be moving that way. Basically, they're going to be increasing quantity, and the only option that each of them has, and that we're going to be considering here, is whether to stay at the current level or to increase by 50. And then we'll see what kind of incentives they're going to end up with. So we're looking for a Nash equilibrium. So it only makes sense to have a payoff matrix, just as before. And again, this is so this is Kevin, this is Russell. Okay, so there are two strategies: are stay at the current level of production. So at the current level of production, each of them is doing 150, right? There are 300 in total, so 150. So quantity is 150, and for this guy, quantity is 150. Or they can increase by 50, which is what we're told in the problem. They can only increase or decrease by 50 gallons. So their other option is to produce 200. All right, so we actually solved this a couple of problems ago, right? What do you think is going to happen here? What do you think the outcome is going to be, the Nash equilibrium? Yeah?
I think they're both going to want to have a quantity.
They're both going to end up with a higher quantity, which is, this is again going to be a prisoner's dilemma, right? Okay, so let's see why. At a quantity of 150 each, they made 90 in total and 45,000 each, correct? So their payoff here, or their profit here is 45, 45. If both of them produce 200, okay, what is the total quantity in the market? 400. So we're going to end up here, right? Ending up here gives us a price of 200, and so the profit that they're going to get is 40 each. Agreed? All right. But what's going to happen if only one of them decides to increase while the other stays where they are? So if Russell, let's say, is at 150, but Kevin, was it Kevin? Yeah. Kevin increases to 200, then what's the total in the market? 350, right? So we're here. At 350, the price is 250. Okay? So one guy produces more, the price goes down to 250. Okay? And what is that? He produces 200 times 250. That's $50,000 for Kevin, right? For the guy who decides to move down. So Kevin is going to get 50. And what is going to happen to Russell's profits? Well, he's going to be still producing at 150, but now the price is lower. All right? So he only is going to get 37.5 thousand. And if you want to feel this, this is going to be the opposite. So Kevin is going to get the 37.5 if he stays at 150, and Russell is going to get the 50. All right, so let's play the game now. If I'm Kevin, given that Russell stays at 150, what should I do? Increase to 200, right? Because I'm going to get 50 then. And then again, I'm Kevin. Given that Russell increases to 200, what should I do? Go to 200, right? Because there's 40 versus 37.5. All right? And if I'm Russell, so given that Kevin stays at 150, what should I do? Go to 200 because it's 50 versus 45. And given that Kevin stays increases to 200, what should I do? Increase to, right? Because it's 40 versus 37.5. And just as before, we saw that this is the Nash equilibrium, right? Both of them increase quantity, end up with a lower profit, right? However, now we're talking about socially optimal outcome, right? They do end up with a lower profit, but those are not the only players in the market, right? Now people would be able to buy water for less. Basically, the price of water is going to be decreased from 300 to 200, so the consumer surplus is going to increase now. Okay. All right, so question, well, sorry, what's the answer here? What is the price after they reach a Nash equilibrium? Well, the price is where both of them produce 200, so the price is 200, which is B. Okay. Same scenario. The question is, what would the market price be if the market for safe drinking water was perfectly competitive? We kind of answered that already, right? If it's perfect competition, what's the price? 0. The price will be equal to the marginal cost, but the marginal cost is 0, so price is going to be 0 as well. That's answer A. All right. Okay, so what do we have here? We have the average total cost curve. The shape of the average total cost curve reveals information about the nature of the barrier to entry in this market. Which of the following monopoly type best coincides with this figure? The natural monopoly, right? So basically, by definition, natural monopoly is when the average total cost is decreasing with quantity, right? So it's always going down as you increase quantity instead of going down and then going up at some point. And at least in this portion of the curve, we have a natural monopoly, which means that the company is experiencing economies of scale, right? They'll be able to achieve a lower cost if they increase quantity. And if a new firm comes, right, the new firm is going to be at a higher total cost. So for them, it doesn't make sense to enter. That's the natural monopoly barrier to entry. Okay, this is relatively straightforward, so that's D. Okay. Alec is a lawyer. He was earning $200K at a major law firm. So he decides to open his own firm. He's cashing in a bond that was earning 10% on a $100,000 principal. He also borrows $100,000 from the bank, again paying 10%. Hires a paralegal for $100K and rents a place for $100K. How much revenue does he need to earn in a year in order to make 0 economic profits? Okay, so the keyword here is economic profits, right? Versus what kind of profit? Accounting, right? So we need to consider both the accounting cost and the opportunity cost of this business. To get 0 profits means that his revenues need to be equal to his costs, right? Total revenue must be equal to total cost. So what this question is asking, in other words, is what are the total costs, total economic costs in this venture, right? So some of those are going to be accounting, and some of those are going to be opportunity costs. The total would be the economic, right? So let's classify. Okay, Alec is a lawyer who was earning $200,000 at a major law firm. What type of cost is that, if it's a cost? Sorry? Opportunity costs, right? So that's $200,000 there. He decides to open his own firm by cashing in a $100,000 bond that was earning 10%. What does that imply? $100,000 bond that was earning 10% now needs to be cashed in. Yeah? A $10,000 opportunity cost. That's all there is to it. All right? The $100,000 principal, you still have it. Whether it's in the bank or in the firm, it's there. It's not a cost. However, if you did not invest that in the firm, you could have earned the 10% on that. So that's the opportunity cost of that bond, which is 10. He borrows $100,000 from the bank at a 10% interest. 10,000 accounting. That's purely related to the business. Hires a paralegal at $100 per year. Accounting, right? That's straightforward. And the rent, the same accounting. All right. So accounting costs are $210, and opportunity cost is also $210. And there you go. Right? So he needs to earn at least $420 in order to get a 0 economic profit. So that's D.
For him him borrowing the 100,000, since it doesn't say whether that was 100% necessary for him to borrow that money in order to create the business, wouldn't you say that it's hard to decipher whether or not you would include that in the calculation? Because it doesn't say, okay, he needs that 100,000 in order to start the business.
All right, so the question is whether it matters if he needs the money that he borrowed or not, as to whether you include it as a cost. It doesn't matter whether he needs it or not. If he decides to borrow it for fun, that is still a cost. He still needs to, so for the bank, it doesn't matter why you borrow the money. You still need to pay the bank the 10%, right? So in terms of a cost, it's always going to be there. He needs to pay it, even if he doesn't need the money.
Did you include it in the calculation?
Sorry?
Did you include the full 100? Because you only included 10,000. So
No,
what I'm saying is,
right. So we
when
don't include, in terms of costs, think about balance sheet versus income statement. Here we're interested in the income statement costs. All right. So the $100,000, he didn't lose it. It's still there, right? For example, he took the 100,000 and
Right,
paid rent,
okay.
right?
Yeah.
So it's not like he paid it to somebody. It's still there, but it's considered, only the interest is considered a cost. All right. Okay, so a chipset in the iPhone 6 is responsible for transmitting voice and data. If the price of this chipset goes up, what happens to consumer surplus for iPhone? All right, so let's think of it. This is purely supply-demand question. Supply, demand, quantity, price. All right, so this is the market for iPhone. There's a chipset within the iPhone, and the price of that chipset goes up. What is the consequence for this market? First of all, first question you need to ask yourself, are we going to see a movement along a curve or a shift in a curve? Shift. And which curve is going to be shifting? Supply. Up or down? Left. Down, right? So supply is decreasing, which is a shift to the left. All right. So that's the new supply curve. Question is about... The question is about consumer surplus. So original consumer surplus is this, correct? That's above the price, below the demand curve. Now with the shifted supply, the consumer surplus is this, right? Again, above the price, below the demand curve. So what happened to it? Decreases. It's pretty straightforward. Right, so in questions like this, it really helps to draw the picture. You can clearly see what's going on. Question, yeah?
If supply decreases, doesn't demand decrease as well?
Sorry. The question if supply decreases, doesn't demand decrease as well? No. The quantity demanded decreases. Demand does not decrease. Right? So you need to make a distinction between a shift in a curve versus a movement along the curve. A shift in the supply curve causes a movement along the demand curve, but the demand curve itself does not shift. All right? Which of the following will cause a decrease in producer surplus? All right, so again, look at the picture and see what's going to happen. Okay, so this is original scenario. We're interested in producer surplus in this case, right? So it's this part that we want to see what's going to happen to. Above the supply curve, below the price. Okay, so the imposition of a non-binding price ceiling in the market. Okay, price ceiling puts an upper limit to the price. However, it says non-binding. If that's the case, then nothing's going to change, right? If it's binding, then it's going to be that's going to affect the market. But if it's not binding, then it stays exactly the same. So that's not it. Buyers expect the price of a good to be higher next month. All right, so think about this logically. What happens here? This is today, right? Buyers expect the price to go up. So what they should do today? buy more. Okay, and the way to what is the effect in terms of the picture?
Should I increase?
Increase in demand, shift to the right. Okay, so if they buy more today, then demand moves that way. And what happens to producer surplus? We need something to decrease it, right? That's the question. So that's not it either, right? The price of a substitute increases. All right. Substitute, think Pepsi and Coke. Right? Those are the regular example given in this case. If this is the market for Pepsi, the price of Coke goes up. What would consumers do? They don't care what kind of Coke they drink, right? They don't care if it's Coke or Pepsi. Let's say they're perfect substitutes. So if the price of Coke goes up, what happens to the market for Pepsi? Demand goes down or goes up? Up, right? Because now it's so expensive to buy Coke that everybody's going to just buy Pepsi. So demand goes up, exactly the same effect, right? Surplus, producer surplus goes up. So that's not it either. We need something to decrease. And the only one left is D. But what happens in D? Income increases, and buyers consider the good to be inferior. Right? So by definition, an inferior good is when income goes up, but you end up buying less of it. Right? That's the definition of inferior good. So what happens with increasing income and inferior good? Demand shifts to the left. Right? They have more money, so they're buying less of it. Think of it as bus tickets versus cars. Right? People get more money, they buy a car and no longer buy the bus ticket. So in the market for bus tickets, there's going to be a shift in demand to the left. And when demand decreases, producer surplus decreases as well. So D. All right. Suppose an increase in the price of plastic coincides with an advance in the technology of iPad production. As a result of these events, the demand for iPads, now let's see what happens to the demand for iPads as well as the supply of tires. Okay, so we have two different markets here. Again, let's consider iPads first. Okay, we have supply demand. So what happened there? There was an advance in the technology of iPad production. What does that do?
More supply, it's cheaper.
Supply is cheaper, right? So now it's easier to produce them, so supply is going to increase. An increase in supply is a shift to the right, correct? So the new supply curve is here. The question is, what happens to demand for iPads? It stays the same, right? This is a supply effect. So the only, well, this is possible, this is not true. And this is possible, but we don't know yet, right? Okay, so now let's think about the market for tires. So the technology advance we took care of. There's also an increase in the price of plastic, and tires are going well. So what happens in the tires market? Okay? Increase in the price of plastic. What's that going to do to the tires market? Less supply, right? So now it's more expensive to produce them, so supply is going to be lower, which is a shift to the left, well, or a decrease in supply. So that will be B over there, right? That's the one. All right. All right. Firm A produces 30 tons of pollution. Its cost of reducing 1 ton is $100. Firm B produces 20 tons, cost is of reduction is 200 per ton, and firm C produces 20 tons of pollution, cost of pollution reduction is 400 per ton. If the government gives firm A 15 tradable pollution permits, and B and C 10 each, when each permit grants the right to 1 ton of pollution, what will be the total cost of pollution reduction? All right, so let's create a table that's going to help us see what's going on. So we have three firms, A, B, and C. We have current pollution, so they're polluting, what is that, 30 for A and 20 for B and C. Then we have cost of reduction. So in order to eliminate 1 ton of pollution, A needs to pay 100 per ton, and B needs to pay 200, and C needs to pay 400. Okay, and then finally permits. So the government gives A 15, and those guys 10 each. All right, so what is going to happen in this market? Looking at firm A, they're polluting 30 units now, right? They're given a permit for 15. That means they need to eliminate 15, right? B is polluting 20, given a permit for 10, so they need to eliminate 10, and the same for C. Is that what's going to end up happening in this market, or is there a more efficient outcome? Right. So they have tradable permits, right? So they can trade with each other. Correct? And who do you think is going to want to buy the permits the most? C, right? Because for them it's so expensive to reduce pollution that they would want to have as many permits as they can get. And they'll be willing to pay a lot for it too, right? They'll be willing to pay up to $400 per permit. And now think of A, for example. For A, it only costs 100 to reduce pollution. So would they be willing to sell their permits to C? Right? Because C can say, I'll give you $399 per permit. Sell it to me. And they will. So basically, but C only needs 10, right? Because they already have 10, so they need another 10. So let's put this permit after trade. Right? So C is going to buy 10 for sure, because for them it's so expensive to reduce pollution. So they're going to end up with all the permits that they need. Okay? Okay, what about B? Well, for them it's also kind of expensive because they need to pay 200. All right? They only have 10 permits. So they will also want to buy from another firm. Well, since A already sold 10, right, to C, A only has 5 available. And B is going to be willing to buy those 5. And they'll be paying, let's say, $199 for them. Right? And so they're going to end up with 15 permits. And A has 0. So 5 go there, 10 go there. They have 0. So the question is, what would be the total cost of pollution reduction? Well, A needs to reduce, what is it? They have 0 permits, so they need to reduce all of it. Right? They need to stop polluting altogether. And they have 30 units at 100, that's 3K. Right? So for $3,000, A is going to eliminate all pollution because they have no permits. The cost for C is going to be, for C, the cost of reduction, 0, because they're not reducing anything, right? They have all the permits that they need. And the cost for B, they have 15 permits. They produce 20, so they need to reduce 5 5 times 200 each is 1,000. So the total reduction is going to cost $4,000. Okay? That's answer B. All right, that's that. All right, so we have a supply curve, demand curve for widgets. Prices in dollars, quantities in thousands, right? If there is a 6 per unit negative externality associated with this market, what is the socially optimal quantity? Okay, so again, we're given the curves in terms of equation, and let's draw the picture now and see what's going on. Price quantity. Okay, so what we have, the intercept here is 40, right? That's the demand curve. And supply is at 8. That's the supply curve, right? So there's a 6 per unit negative externality associated with the production of widgets. What does that mean? Well, it basically means that the supply curve that we have here, it does not reflect all the costs of this good. This is the private supply, right? And the social supply that includes both the private costs and the external costs is going to be, well, the cost is higher, so the supply curve is shifted to the left. So at any quantity, the cost would be higher, right? So the supply curve would be higher. And that's by 6. Vertically, the difference would be 6, right? So there's a shift in the supply curve. This is then 14, okay? This is the social cost that includes the externality, and this is the private. That does not account for it. The question is, what is the socially optimal quantity? But the socially optimal quantity is where the demand curve and the social cost and the social supply curve intersect, right? So socially optimal quantity would be here, which is lower than the privately optimal quantity, right? The one in equilibrium in this market. And that makes sense, because here producers are willing to, they're producing more because they don't pay the extra cost, right? However, if the extra cost was accounted for, then they will be producing less. And we need to find what that is, all right? So either way, we can set the demand curve equal to the socially optimal supply curve. So we would have 40 minus 1.5, and that will be the socially optimal quantity equals. Now, what is the social cost curve? Well, it has the same slope, right? But the intercept is shifted by the externality cost, by the external cost, which is now going to be 14 instead of 8, and the same slope, so the rest of it is the same. Right? Does that make sense? So we're just setting the two curves equal to each other, but the correct curve in this case, which is $6 higher, shifted by $6. Or you can do the difference. So we also know that the difference between the supply curves is going to be 6. But either way works. So what do we have here? 26 equals 2. So the socially optimum quantity is 13. Agreed? So we know this here is 13. And that's answer B. Question?
For under social cost, you have what you say in parentheses next to the S on the graph.
I'm sorry. I couldn't. On the graph, that's what does it say here?
No, in the parentheses where it says S and the
It's part of the course.
Oh, private. All right, so again, the same scenario. The question is if the world price. All right, so we don't have any externality. This was for the previous question, right? So we're in the original scenario where we just have the two curves. Okay, so I have 40 here and 8 there, supply and demand. Right? Original scenario. If the world price of widgets is $10, what would be the gains from trade to a country with the domestic supply and demand equations represented in the scenario? Okay, so in order to see, but we don't know whether the $10 world price is above or below the domestic equilibrium. So that's what we need to figure out first. Right? We need to know what this price, this quantity is. And just, again, set them equal to each other and solve for quantity. We have 40 minus 1.5, and this is the quantity equilibrium equals 8 plus 0.5 quantity equilibrium. What is it, 32, 16? Yeah. So 32 equals 2 quantity, the quantity equals 16. Right? Price 16 again, right? 8 plus half of 16. There you go. So without the international trade, that's what's going to happen in this market. Then the world price is $10, right? So now we know the world price is lower than the equilibrium price in this market. So what are we going to do if we allow for trade? We're going to import or export? Import, right? Because at that price, demand is higher than supply. And what are the gains from trade? So the gains from trade are defined by the increase in total surplus due to the open trade with the rest of the world. The total surplus before opening the market was the regular one, right? The area of that triangle. But now since we allow for trade, we are also adding this part here to the consumer surplus, right? So total surplus after trade is actually that figure, right? So this part is the consumer, the producer, and this part is the consumer surplus. Producer surplus is decreased. However, consumer surplus is increased by more than that. All right, so the net effect is actually positive, which is what the gains from trade are. And the gains from trade would be the area of this triangle here. All right. The formula for the gains from trade. Well, this would be the quantity demanded minus the quantity supplied, right? That's that side. So that's quantity demanded at the world price minus the quantity supplied at the world price times, and then that's the difference between the domestic price and the world price, right? The height of this triangle would be the difference between domestic and world. And the whole thing divided by 2. Okay? So what do I know? I know the world price, that's 10. I just found the domestic price, that's 16. I haven't found what the quantity demanded and the quantity supplied is at the world price. Right? That's easily done. Right? So using the formula for the demand curve, what will be the quantity demanded at the price of 10? Well, it's 40. Sorry. Well, okay. So we need to find the quantity at the price of 10. So plug in 10 for the price and solve for the quantity. And then plug in 10 for the price and solve for the quantity supplied. Okay. So I have 10 equals 40 minus 1.5, the quantity demanded. Okay, 1.5 quantity demanded equals 30. So quantity demanded is 20. Right, so now this point is 20. And then for the supply curve, do the same. 10 equals 8 plus 0.5 quantity supplied. So 0.5 quantity supplied equals 2, or quantity supplied equals 4. So that's this point here. Right? Now I know all that I need in order to find the gains from trade. Quantity demanded was 20 minus supplied, which was 4, times the domestic was 16, world was 10, the whole thing divided by 2. What is this? 16, 8, 48. Right? That's 48, but the quantity is again in 1,000. So for 48,000. That would be the area of this triangle here. And that's what the gains from trade are. Okay, questions? All right. All right, suppose the price of good X is 4, the price of good Y is 3, and consumer income is 180. If the price of good X drops to 2, which of the following statements represents the income effect? Okay, so now we have consumer choice here. We're given budget lines, and we're also given a couple of indifference curves. All right? First we're told, so this is good, the quantity of good X versus the quantity of good Y. And good X, first we're told the price of good X is 4. Okay, so if the price of good X is 4 and consumer income is $180, what is going to be the X-intercept? Okay, so if price of X is 4 and income is 180, to find the intercepts here, you need to ask the question, if I spend all my money on that good, how many units can I buy? Right? So I have 180. Each of them costs 4, so I can buy 45 units. So this is one of my intercepts. Right? And then the price of good Y is 3. So if I make 180, how many can I buy? 60. So that's the other intercept. Therefore, initially, we're on this budget line, right? What bundle are we consuming initially? What bundle of goods? Which one? A, B, C, D, E, and F. Initially, right now, that's our budget line. Which bundle are we consuming right now? B, right? By definition, the optimal consumption bundle is the one where the marginal rate of substitution is equal to the slope of the budget line. In other words, where the budget line is tangent to the indifference curve. It's tangent at this point, right? So we're going to start at point B. Then what happens? The price of good X goes down to $2, Y is still the same. So this intercept is the same, because the price of Y didn't change. However, because the price of X went down to 2 with 180 bucks, now we can buy 90 of this if we want to spend all our money on it. So basically, we're moving to the other to the other budget line. What's going to be our consumption bundle then? A, for sure, right? We're going to be here. All right, good. So now we're going to end up from B to A. However, there are a couple of effects that are taking place here. One is called the substitution effect, the other is called the income effect. The substitution effect is basically the the movement along the original indifference curve. Right? That the substitution effect is the fact that we are now able to buy more of x because it's cheaper, so we're going to buy less of y, which is basically moving down this way. And then there's the income effect, which is putting us on a higher budget line. So there's a movement along the indifference curve, which is the substitution effect, and there's a jump to the new indifference curve, which is the income effect. So we know the income effect. We're asked about which of the following represents the income effect. We know the income effect is going to be a jump. All right? So we know the starting point is not going to be B. The starting point is going to be either here to there or there to there. All right? So from this, B to A is not going to be the answer because that's the whole effect. That's both the substitution and the income. So that's not it. D to A, possibly. B to E. We know that along the curve, along the indifference curve, that's the substitution effect. So that's not going to be an income effect either. And E to A is also possible. So again, we eliminated two. We have only two options left. And the question is the income effect jumping from D to A or from E to A? And what needs to be true? Well, what do we need to find then? The substitution effect moves us from the original bundle to a bundle along the indifference curve that has the same slope as the new budget line. Does that make sense? So the marginal rate of substitution, due to the substitution effect, is going to give us exactly the same number as the slope of the new budget line. And I'm given the slope. At D it's -1, and at E it's -2/3. So whether I'm moving from D to A or from E to A then becomes a question of what is the slope at A. If the slope at A is -1, then that means that I will only go from B to D and then from D to A. If the slope at A is -2/3, then I will go from B to E and then from E to A. So what is the slope at A? It's -2/3. And how do I know that?
-60.
Right. So I know at A, the slope of the marginal rate of substitution, which is the slope of the indifference curve, is exactly the same as the slope of the budget line. And the new budget line has a slope of -6 over 9, or -2/3. Right? It's a change in y over change in x. If you look at here, it's 60 over 90. Right? So it's 2/3. And because of that, so the substitution effect is from B to E, and then the income effect is from E to A. And that's answer D. Given the information represented in the figure, which of the following statements is true? Okay. Whether goods are complements or substitutes, whether good Y is an inferior good, or whether good X is an inferior good. So what I do know here, what happened here is, well, I saw that the price of X, I saw what happened when the price of X went down, right? So as the price of X goes down, what happened with the quantity demanded for those goods? Well, we moved from B to A, right? As the price of X went down, we moved from consumption bundle B to consumption bundle A. So the quantity consumed of good Y, did it go up or down? Right? So quantity Y went down. That's one of the effects. And what happened with the quantity consumed of good X? Well, from B to A, we're consuming more of X, right? So the quantity consumed of X went up. So those are the two things that we know happened when the price of X went down. What can we conclude based on those results? Well, the price of X went down, the quantity of X went up, the quantity consumed. So X is, what we can say here is a normal good, right? Because price goes down, you buy more of it. If it were an inferior good, then as the price went down, you would buy less of it. So we know that X is not an inferior good. We don't know what Y is, but can we say something about complements or substitutes? Well, by definition, how do you define complements or substitutes? By looking at their cross-price elasticity. Right? The cross-price elasticity tells you if the price of one good changes, what happens to the quantity of the other good. And then whether they're complements or substitutes depends on whether the cross-price elasticity is positive or negative. That's kind of, I think, one of your first chapters that you studied. All right? So what happened here? The price of X went down, and the quantity of Y that you buy goes down. Think of this logically. Right? So something became cheaper, and now I'm buying less of the other good. So something became cheaper, I'm buying more of that thing and less of the other. So are they complements or substitutes? Substitutes, right? Pepsi and Coke. If Pepsi is cheaper, I'm going to buy more Pepsi, therefore less Coke. Okay? So I can say that they're substitutes based on this information. That will be B. All right. Again, same picture. Ignore the budget lines drawn. All right, so let's ignore some stuff. Ignore the budget lines drawn. If bundle E is optimal for the consumer, so bundle E is the best choice, this bundle, and good X costs $1, how much does good Y cost? All right. So we know that if this is the optimal bundle, then that must be where the indifference curve is tangent to the budget line, whatever the budget line is, right? It says to ignore the given one. So the budget line is going to be, where? Somewhere here. Something like that, right? What else do we know about the optimal bundle? Because they're tangent, then the slope at bundle E is going to be the same as the slope of the budget line, right? At the optimal bundle, so at E, the marginal rate of substitution, which is the slope at E, right, the slope of the indifference curve, is going to equal to the slope of the budget line. I know the marginal rate of substitution here is negative 2/3, right? I have that. What is the slope of the budget line in terms of economic sense? What does it equal? The slope of the budget line. The slope of any budget line expressed in terms of variables.
How much of certain goods they can get based on how much money they have.
That's not the slope of the budget line. That's what the budget line tells you, but not what the slope of it is. I'm looking for an equation.
Well, it tells you how the prices compare to each other.
Okay, so the slope of the budget line is? No.
Negative 2/3.
No.
It's not?
Well, it's going to be equal to that. All right. So in terms of a form, okay, so what's the budget line? Let's start there. Budget line is the price of X times the quantity of X. Well, that's not the budget line. That's the budget. Okay? So the income that you have is you're going to spend some of it on X and some of it on Y. Right? So it's price of X times quantity of X plus price of Y times quantity of Y. Representing that on this graph, which has the quantity of Y on the Y-axis and the quantity of X on the X-axis, means solving this equation for quantity of Y. Right? In order to get slope, in order to get intercept plus slope times something, I need to solve this equation in terms of quantity Y, which is on the Y-axis. All right. So price Y, quantity Y equals, that's going to be the budget minus price X times quantity X. Still not done, because I need to express y in terms of x, quantity of y in terms of quantity of x. So to do that, I need to divide both sides by the price of y, correct? Then I'm going to get the quantity of y equals the budget divided by the price of y minus the price of x over the price of y times quantity x. Now that we have that equation, which is of the form y equals b plus mx, what is the slope of the budget line? What is the slope of this equation? Y equals b plus mx. What does b represent? Intercept. So what's the slope? All right, so translate that to this equation, which is the budget line. What's the slope of the budget line? A bit more confident? The negative price of x over price of y. All right? So that's what I was looking for. Okay. At the optimal, the marginal rate of substitution equals the slope of the budget line, which also equals the relative price. Okay? Are we good so far? So if we know that the optimal bundle is z, what is the marginal rate of substitution? At point E, what is the marginal rate of substitution? 2/3. We can ignore the negative because both of them are going to be negative, so just keep it positive. So 2/3, which is the marginal rate of substitution, equals the price of x over the price of y. What's the question asking? If it's the optimal bundle and x costs 1, how much does y cost? Now we can answer that question. We have a simple equation, one unknown. Right? We know this is 1, so the question is, what is that? All right? So the price of y is $1.5. And that's answer C. Agreed? Okay, same problem. So if the price of x is 1, the price of y is 1.5. Okay, x is 1, y is 1.5, consumer has an income of 90. All right? What is the optimal consumption bundle? That's relatively straightforward. So if the income is 90, which budget line are we at? Okay, so we have 90 bucks. Good x costs 1. How many can we buy if we spend our money on x? 90. So we're at this point, right? And again, 90 bucks. Y costs 1.5. How many can we buy? 60. So we're basically on this budget line. What's the optimal bundle? There you go. A. All right. Here we have a monopoly. All right. So we have a demand curve, marginal revenue curve, and we're also given the average total and marginal cost. What is consumer surplus if a profit-maximizing monopolist can perfectly price discriminate and there are no fixed costs? Right. So question is, what is consumer surplus if that guy, that monopolist, can perfectly price discriminate? What does that mean, to be able to perfectly price discriminate? Right. Charge every person what they're willing to pay. Right? So if I'm willing to pay $5 and you're willing to pay $10, they're going to charge me 5 and you 10. Right? So what's going to happen with consumer surplus then? No consumer surplus. Right? Consumer surplus by definition is above the price, below the demand curve. So it's above the price that I'm paying, below what I'm willing to pay. But in this case, what I'm willing to pay is what I'm paying. They're charging me the maximum that they can. So consumer surplus with perfect price discrimination is 0. Then producer surplus is all of it, right? They take all of it. So here it's C. what is total surplus if they can price discriminate perfectly? Well, total surplus would be what they make. And, well, so basically that would be, the total surplus is going to be as before, this whole thing, but just all of it goes to the producers, right? Because they're charging this person 15, this 16, and so on and so forth, right? So consumers get nothing, and total surplus is the area of that triangle which goes to the monopolist. All right, so area of that triangle, well, the base is 30, right? The quantity or the height is 15. So total surplus equals 30 times 15 over 2, 225. That's A. Agreed? What is deadweight loss if the industry is served by the profit maximizing non-price discriminating monopolist rather than a perfectly competitive firm? All right, so we know perfectly competitive outcome would be at that point where the marginal cost and the demand curve intersect, we have 15 price and 15 quantity produced. That's perfect competition, socially optimal. However, this is monopoly now. So there's just one firm that's a monopolist. Their decision rule is, again, where marginal revenue, so they're going to produce quantity where marginal revenue equals marginal cost. That's always going to be the case. However, for a monopolist, that happens, where is it? So this is their marginal revenue curve. This is their marginal cost. That's where they intersect. So they're going to be producing quantity of 12. And how much are they going to be charging? 20, right? So you use the intersection of marginal revenue and marginal cost to find the quantity. And then the intersection between that quantity and the demand curve gives you the price. Right? So don't get confused. That's the price. And that's the whole idea of monopolists. They're going to produce less so that they can charge more and optimize their profits. And what does society lose? What is the deadweight loss? So the deadweight loss is the decrease in total surplus, right, from perfect competition to monopoly. Total surplus used to be that whole thing. And now because they have restricted quantity, it's just this trapezoid. Right? So the deadweight loss would be the area of this triangle. Okay? So the deadweight loss, this is what? This is the price minus, well, the price where the marginal revenue and marginal cost intersect. So that side is 8 times, and that's the height of the triangle is the reduction in quantity, right? It went from 15 to 12. So that's 3 divided by 2, 12. Agreed? All right. Almost done. That's A. Now we have a monopolistic competitor. Okay, monopolistic competition. This is it's kind of a long-run outcome, right? Because they face a demand curve, kind of individual demand curve, because they can either differentiate their product or some kind of competitive advantage. However, there are many firms in this industry. So the long-run outcome for monopolistic competition is still zero profits. However, that zero profit doesn't happen at the minimum of average total cost, right? The zero profits are achieved at a point that is not what we call efficient, right? The efficient outcome would be the perfectly competitive outcome. So what is the efficient scale of production in this question? Sorry? 22. That's what the monopolistic competitor is doing, but that's not efficient. Well, the efficient outcome we know is the perfectly competitive outcome, right? And what does perfect competition tells us? Where do they produce when all is said and done? At the minimum of average total cost. So what's the efficient scale? 28. All right? Basically, everybody ends up producing where it's the cheapest to produce. And the cheapest is at the minimum of average total cost. Okay, so that's a different monopolistic competition. So we have a monopolistically competitive firm in the short run. Which of the following explanations describes the long run adjustment? So let's see what we have currently. So this firm is facing the following demand curve. They are again producing where marginal revenue equals marginal cost, which is here, right? However, just as a monopolist, they're charging more in the short run. So they're producing at 50, but they're actually charging their clients 30. Agree? Is that firm making a profit or a loss? Profit, right? Because the price that it's charging, which is 30 at that quantity, is higher than their total costs, and the total costs are 20. Okay? So they're making $10 difference per unit. So they are producing at a profit. Now this is a monopolistically competitive market. What is going to happen in the long run in that market? So firms are allowed to enter, right? As firms enter, each of them has a differentiated product. So each of them is facing a separate demand curve. However, the products are not that different because it's still within the same market. So as more firms enter, right, what does that cause to the demand curve of this particular firm? So now it has more competitors, right? So there's going to be less people buying their product. So yeah, the demand curve is going to start shifting to the left up until it reaches a point, right, where there's no longer any profits. Then there's no incentive to enter or exit. But that is not going to happen here. That is actually going, because it's only shifting, right? So it's a parallel shift. So the new demand curve needs to go all the way here for profits to be 0. Basically for the price to be equal to the, what is it? To the average total cost. Right? So the difference between that and competition, and perfect competition, is that perfectly competitive firm faced a horizontal demand. So as it shifted down, it actually ended up here at the minimum of the average total cost. That's not going to happen with monopolistic competition. Right. So to answer the question, in the long run, because they're making profits, in the long run, more firms will enter this market. Each firm will have a smaller share of the total market demand, shifting the firm's demand curve to the left. That's actually true, right? That's exactly what happened. More firms will enter, and each firm will have a larger share. That's not true. And then the exit is also not true. The exit is going to happen if there were if they were operating at a loss, right? Then in the long run, more firms will firms will exit the market, and then each of the ones that remain is going to have higher demand, right? Okay, so this was A. Okay, last one. Suppose demand is given by this equation, and supply is given by another equation. Quantities in thousands. What price floor will cause a surplus of 9,000 units? Okay. So again, we have a certain demand and supply curve given. So this intercept is 19. That's the demand curve. And the supply intercept is 1. Okay, so we have a certain supply and certain demand. They're at some kind of equilibrium price. an equilibrium quantity. And the question is, what price floor will cause a surplus of 9,000 units? Okay, so price floor says that we cannot produce at less than that price, right? So to cause a surplus, it needs to be binding. Okay, so the price floor that's binding needs to be above the current market price. So it needs to be somewhere here. This is the price floor. And I want it to cause a surplus of 9,000. So I want the difference between the quantity supplied and the quantity demanded at that particular price to be 9,000. Does that make sense? All right, so let's then express the quantity demanded and quantity supplied as a function of the price, and then look at the difference between the two. But from the first equation, I have that the price is 19 minus quantity demanded. Therefore, quantity demanded is 19 minus the price. Okay, and from the second equation, I have that the supply curve is 1 plus 0.5 quantity supplied. So 0.5 quantity supplied is the supply curve minus 1. So quantity supplied is 2 times the price minus 2. Okay, so those are the two that I'll be using, and I know that at that particular price, which is the same, right, the difference between quantity supplied and quantity demanded must be 9,000. So at the price floor, quantity supplied minus quantity demanded needs to be 9, right? Because quantity is in thousand represented in the curve, so it's just 9. Plug in and solve for the price, and that's all there is to it. So 2p, and I can call this price floor, minus 2. And then minus the quantity demanded, which is minus 19, plus the price floor equals 9. What is it? 30. So 3 times that particular price equals 30. So the price floor needs to be 10. All right. In other terms, in order to achieve a surplus of 9,000 units, you need to set a price floor of $10 in this particular market. So if it were the other way around, if you were asked what would be the price ceiling, that would cause a deficit of a certain amount, then you're going to just switch those. Then you need the quantity demanded minus the quantity supplied to be equal to whatever the deficit it is. Okay? Do you have any questions? Yes?
It seems that all the chapters are kind of evenly covered, and there's a bit more on 17. Is that fair to say? That they're all kind of evenly covered in 17? Or is there more emphasis on information past the midterm?
I can speak because I'm not going to make the exam. So it's up to your instructor to decide that.
It's not a departmental.
I'm not sure. All right, guys. Thanks for coming.